Hello friends, again this is Kaustu Pathare again with a new video. Welcome to our channel Making Maths Easy. Today in this video we will prove this logarithmic equation. So we will take first of all left hand side, which is LHS. The LHS is equal to this log of square root of 8 plus log of square root of 27 minus log of square root of 125 divided by log of 6 minus log of 7. So we will take this and we will paste it here. So after taking the LHS, uh, we will simplify the LHS and we will try to bring the RHS out of LHS. So what is log of square root of 8? First we will choose the divide operator here. So log of square root of 8 can be split or can be bifurcated into two terms, which can be written as log of square root of 4 multiply by 2. Then log of 27 can be written as log of 3 raised to 3, as 3 into 3 square becomes equal to 9. So 3 into 3 into 3, so 3 times 3 gives you 27. This log of 8, which is square root of 8, which is square root of 4 into 2, can be also written as 2 raised to 2, 2 raised to 3. Now one another thing, log of 125, log of 125 can be written as log of square root of 5 raised to 3, as 5 multiplied by 5 multiplied by 5 gives me 125, and downwards I will write it as it is log of 6 minus log of 5. Okay, now the another step is we will split the square roots. So I will choose the divide operator and then log of now it is 3. So what is a rule, what is the law of indices for a square root? For a square root, the law of indices is 1 by 2, means anything in the root. Suppose 2 square root of 2 means 2 raised to 1 by 2, so it can be written as log of 2 raised to, here it is 3 raised to 3, so 3 divided by square root means 2. Now for second, log of 3 raised to 3 divided by 2, as it is square root. So remember one thing, whenever there is a square root, we will take if whenever there is a square root, the power become equal to 1 by 2. Whenever there is a cube root, the power become equal to 1 by 3. Fourth root, the power become equal to 1 by 4. In this case it is square root, so power I have used here 1 by 2, and 3 is my 3 is my 3 raised to 3. Here 3 is my 2 raised to 3. Now similarly minus log of 5 raised to same 3 by 2. Now come to the denominator. In the denominator we have log of 6 minus log of 5. Now we will use the logarithmic functions or logarithmic properties in order to simplify this. As we know that log of a raised to b is equal to b log a. Similarly we will use, as log of 2 raised to 3 by 2 gives me 3 by 2, 3 divided by 2, give a bracket, log of 2, close the bracket, plus 3 divided by 2, take a bracket, log of 3, close the bracket, minus 3 divided by 2, take a bracket, log of 5, close the bracket. Now come to the denominator, log of 6 minus log of 5. Now next step will be, we will take 3 by 2 in these three terms. 3 by 2 is common, so we will take 3 by 2 as a common. So we will take 3 by 2 outside. So 3 divided by 2 can be taken as outside. Take a long, take a big bracket and write log of 2 plus log of 3 minus log of 5 and close the bracket, and divide this whole thing by, take another bracket, log of 6 minus log of 5. Now 3 by 2 we have taken 3 by 2 as a common. uh, Now use the property of logarithm in order to simplify. And the most important property of logarithm in this, log of a, log of a plus log of b equal to log of ab. Now we will use this property in this case. So here we will write 3 by 2 and bracket, and we will use the first, we will use this divide operator. We can use and we cannot use the divide operator, it's one and same. You can also use many other operators. So log of 2 plus log of 3 gives me log of, write a bracket, 2 into 3 minus log of 5, and which is divided by log of 6 minus log of 5. Now we are near to the answer, or we are near to the RHS. So log of 2 into 3 gives me, log of 2 into 3 gives me log of 6. So it can be written as log of 6 minus log of 5 divided by log of 6 minus log of 5. So in both the cases, we will divide log of 6 minus log of 5 with log of 6 minus log of 5, which gives me equal to 3 divided by 2. So my final answer is 3 divided by 2, which is equal to, RHS. So hence we have proved this. Okay, so let's move to the next sum. So this is our next sum. Here it is, a raised to x is equal to b raised to y is equal to c raised to z, which is also equal to d raised to w, where a is not equal to 1, and we have to prove that log of abcd base to a is equal to x into 1 by x plus 1 by y plus 1 by z plus 1 by w. So we will take a variable as a k. So let us consider k is not equal to 1. Let k be the variable which is not equal to 1, and we will take, so k becomes equal to a raised to x, k equal to b raised to y, k equal to c raised to z, k equal to d raised to w. Now we will write, now we will look at the thing which we have to prove. We have to prove that log of abcd base to a is equal to x into 1 by x plus 1 by y plus 1 by z plus 1 by w. So we want a, b, c, d in this case. So write k, don't write k, write a equal to k raised to 1 by x b equal to k raised to 1 by y, c equal to k raised to 1 by z, d equal to k raised to 1 by w. So we have found out the values of ABCD. Now we want to multiply ABCD together. So we will write ABCD equal to k raised to 1 by x multiply by k raised to 1 by y multiply by k raised to 1 by z multiply by k raised to 1 by w. Now we have found out the values of ABCD, as it is 4 times k multiplication, 4 times k, not 4 times k, k raised to 1 by x, 1 by y, 1 by z, 1 by w. So according to the law of indices, ABCD equal to k raised to a combination of k raised to a combination of all this. So we will use a divide operator here. 1 by x plus 1 by y plus 1 by z plus 1 by w, and we will close it. Now remember one thing, as we know that value of k is equal to a raised to x. We know that value of k is equal to, we know that value of k is 1, value of k is a raised to x. So instead of k we can write a raised to x. So a b c d equal to a raised to x multiply by this. As we know that a raised to x, so a raised to k, the value of k is a raised to x, and k, the power of k is also this 1 by x, 1 by y, 1 by z, 1 by w. So in this case a raised to x, so x will be multiplied by this. If we will if we will replace the k by a raised to x, so x will be multiplied by all this. Remember this thing, we don't have to power of all these things, means power on power on power on, no, we have to multiply the value of k with this 1 by x, 1 by y, 1 by z, and 1 by w. Now take log on both sides. Taking log on both sides, log on both sides. So after taking log on both sides, we will get log of ABCD equal to log of a raised to this function. Now according to the law of logarithm, we know that log of a raised to b is equal to b log a. So I will write the property by log definition, log of a raised to b is equal to b log a. So we will use the same property as we know that log of a b c d equal to this function into the log of a. So another one property is log of a will go in the denominator as it is in the numerator, so we will send him in the denominator. So log of a b c d will be divided by log of a, which gives me equal to this particular expression x into 1 by x plus. So this is our uh, simplification. Now further we will simplify. So we will divide log of a b c d by log of a. So this log a will go in the denominator, become equal to this. So we know a property of logarithm. According to the property of logarithm, uh, log of a divided by log of b equal to log of a to the base of b, log of a to the base of b. So similarly log of abcd divided by log of a gives me log of abcd to the base of e. So log of abcd to the base of log of abcd log of abcd to the base of a, abcd to the base of a, which is equal to this. So hence we have proved the mathematical function as log of abcd to the base of a is equal to x into 1 by x plus 1 by y plus 1 by z plus 1 by w. So if you like my video, please share, subscribe and comment on my YouTube channel Making Maths Easy. For more videos related to the mathematics, please subscribe my channel. Thank you for watching.